Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of geography for the course of Bachelor's in Arts with Geography and Bachelor's in Arts with Honors in Geography. The video is for the paper of Climatology, Module 2, which is Solar Radiation, Heat Balance, and Temperature. Today we will be starting with Lecture 5 of Module 2, which is Distribution of Temperature on Earth. The video is being recorded by Dr. Pallavi Upreti.
The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. We have already covered temperature on Earth and what are the factors which affect the temperature distribution on Earth. Today in this particular lecture, we will be starting with the temperature distribution on Earth. That is the temporal distribution of temperature on Earth, that how the temperature of Earth has changed over millennia since its inception. And we will also be covering the spatial distribution of temperature, vertical distribution of temperature, and regional distribution of temperature on Earth. So let's begin.
The objective of this particular video is to understand the distribution of temperature on Earth, which will include temporal distribution of temperature, spatial distribution of temperature, which will be further divided into vertical distribution of temperature and horizontal distribution of temperature. And finally, we will try to understand what is the regional distribution of temperature and what are the heat zones of temperature on Earth. The average temperature of Earth is a fundamental part of what allows Earth to be habitable. As we know that Earth evolved as hot rotating ball of gases somewhere around 4.5 billion years ago. This hot rotating ball of gases gradually cooled down to its present shape and form. And over this evolution of Earth's geological past, the temperature on Earth has also fluctuated tremendously. Of all the planets we know today, Earth is the only one to support life. And this is why, because it has perfect temperature and it lies in the Goldilocks zone, which is in a perfect distance from a star. In our case, we have sun. And in terms of temperature, it is neither too hot nor too cold, and it supports life. The interaction between solar radiation, Earth's atmosphere, Earth's surface, and several other factors distribute heat on Earth to maintain its specific temperature and to support life. And this heat is recorded in terms of temperature. This is called as temperature. The distribution of temperature on a planet is very, very significant, not only in terms of supporting flora, fauna, life, but also in Earth's atmospheric and geological processes, because these processes are dependent upon this balance of heat, balance of temperature, upon the distribution of temperature which is found on our planet. The wind circulation, existence of different climatic zones, and several other weather patterns and phenomena are heavily dependent upon the distribution of temperature on Earth. So temperature on Earth, its distribution is very, very important for life on one hand and for supporting the physical and geophysical processes on the other hand. The distribution of temperature of our planet can be studied in two broad ways. First is on the basis of time or temporal distribution of temperature, which means that how the temperature of our planet, how the temperature of Earth has fluctuated over its geological time period, how at one point of time it was very, very hot, and then over several thousand years it settled down to its current temperature. So when we take and look at the temperature of Earth from the perspective of time, how it has evolved, how it has changed, how it has reduced, decreased, increased throughout the geological time period, it is called as temporal distribution. And second, we have when the distribution of temperature is studied on the basis of space, how spatially the temperature varies from one place to place, or even at the same place, how it has evolved over the time period. So spatial distribution of temperature is space-based, and temporal distribution of temperature is time-based distribution of temperature. When we talk about the temporal distribution of temperature, it is very important to understand that the Earth's temperature has fluctuated dramatically many times since the planet was formed 4.5 billion years ago. So, at one point of time in geological past, the temperature of Earth was very, very high, and over the geological time period, through series of changes that happened during the course of its evolution, the global temperature has also fluctuated and settled to its present form today. So most past changes in the global temperature occurred slowly and over millions of years. And these changes can be associated with the evolution of Earth itself, because at one point of time we didn't have any atmosphere, so atmosphere came into existence. Later on, the crust was formed. Gradually, the Earth started to cool down, the oceans came into existence. Then there was tremendous amount of greenhouse gases in the atmosphere, which were very, very high in the geological past. So their percentage also came down, and along with the evolution of cycle of sun and the atmosphere, its composition, the temperature also fluctuated dramatically over the geological past and settled to its current position today. So all these factors, these are the factors which led to the current state of temperature on Earth. So today the scientists have reconstructed a record of Earth's past climate, paleoclimates on evidences like freezing, ice core studies, ocean sediment studies, coral reef studies, sedimentary rock studies. So through several studies, the scientists have been able to reconstruct the climatic past of our planet to understand the temporal distribution of temperature on Earth. In order to better understand the temporal distribution of our planet, the scientists have studied several evidences which are present on our planet, and they have compiled a continuous high fidelity record of variation in Earth's climate extending 66 million years into the past. So scientists have been able to successfully construct the record of climatic conditions of 66 million years into the past. And these records reveal that there were four distinctive climatic states which existed on our planet during its geological course of time. And these were hot house, warm house, cool house, and ice house. During the early Eocene, as you can see in this particular diagram, during the early Eocene epoch, the temperature of our planet was very, very high. Average global temperature was 9 to 14 degrees Celsius higher than what we have today. And this particular time period has very high emission of greenhouse gases also in the atmosphere, particularly carbon dioxide concentration was very, very high in this particular time period in the atmosphere. And at that point of time, we didn't had any polar ice caps also to hold these greenhouse gases. So the temperature was very, very high. But when the Eocene epoch ended, somewhere around 35 million years, the Earth entered into a cool zone. The Earth's temperature entered into a cool zone, which is called as cool house. So since the Eocene epoch ended, we have a cool house state. And for the past 3 million years, the Earth has remained into the ice house state. It further decreased because the temperature further decreased over the geological past, and we entered into the ice house stage with several interglacial periods in between. But when we talk about the temporal distribution of temperature, it is also imperative to understand the changes in temperature and climate which are happening today since the evolution of man also. So the temporal distribution of Earth not only talks about the temperature changes which have happened in the geological past, but also the changes which are happening in the recent past, the temperature which has fluctuated, the climate change which has happened in the recent past, all is studied as part of temporal distribution of temperature on Earth. So as the planet moved out of the last ice age over the past million years, the global temperature rose to just 4 to 7 degrees Celsius over about 5,000 years. So in that 5,000 year of time period, the global temperature just increased to 4 to 7 degrees Celsius. Climate and sea level were relatively stable over thousands of years of recorded human history up till 19th century. Although with some variation, the global average temperature have increased over the past century. So, global average temperature have increased over the past century, and human actions may be primarily attributed or considered as significant causes is primarily after the Industrial Revolution. So temporal distribution of temperature also include the human-induced changes in temperature, climate, which have happened in the recent past of history. So the average global temperature hovered around 13.7 degrees Celsius in the 18th and the 19th century. But since the 19th century, primarily after the Industrial Revolution, the planet average surface temperature has risen about 1.18 degrees Celsius, a change which is driven largely by the increase of greenhouse gases concentration, especially carbon dioxide emissions into the atmosphere and other human activities. So here in this particular diagram also you can see that the average global temperatures till 1920s just remained to 13.7 degrees Celsius. However, after that, primarily when the Industrial Revolution took off and it kind of expanded to the entire world, the temperature increased, and today the global temperatures are more than 14.3 degrees Celsius, 14.7 degrees Celsius on an average, which is very much above the temperature which were in the 19th century or the 18th century. So they were 1.18 degree higher than the average temperature which were in the entire 19th century. Because of all the human activities which are contributing to increase in the greenhouse gas emissions, especially after the Industrial Revolution took off, these human activities are driving the planet towards the warm house and hot house climate state, which has not been seen since the Eocene epoch ended 35 million years ago. So the conditions today which are prevailing and which are being mainly induced by the human activities are actually driving our planet to the condition which existed previously in the geological past, where the temperature of our planet was very, very high. The world's seventh warmest year of all occurred since 2014. So you can understand the gravity of the situation here, that how quickly we are proceeding towards moving to hot out climate state on our planet, that since 2014, the seven warmest years of the entire millennia has happened in these particular last 10 years only, and within which 2016 was the hottest year of the entire millennia. Primarily because of the human-induced activities, you can see in the recent past, the temperature have increased tremendously. And here in this particular graph also you can see the level of increase of temperature is very, very high, especially after 1940s time period. So the 2020 temperature was 0.98 degrees Celsius warmer than the entire 20th century average of 13.9 degrees Celsius. And it was 1.19 degrees Celsius warmer than the pre-industrial time period, which is 1880 to 1900. So this makes it very, very clear that the actions which we are doing today, the human-induced activities, which are primarily contributing to the increase in greenhouse gases is going to affect the temperature in the coming future. And the temporal distribution of temperature does not only include the study of the geological past, the conditions of temperature which occur in geological past, but also the present conditions, the conditions in the recent past on temperature, and the activities and the conditions which may contribute to the temporal distribution of temperature in future. Besides temporal distribution of temperature, we have spatial distribution of temperature also. The distribution of temperature over space or temperature distribution in different places on the Earth's surface across latitude or along the vertical dimension above the ground surface is called as spatial distribution of temperature. So, beyond time, when we talk about the vertical space, which is above the surface of Earth, or horizontally along the latitudes, when we talk about the distribution of temperature, it is called as spatial distribution of temperature. While we have already studied the various factors which are responsible for spatial distribution of temperature, particularly horizontal distribution of temperature and also vertical distribution of temperature, today we will try to understand what horizontal and vertical distribution of temperature exactly is and how the temperature is distributed vertically and horizontally over the space. So, the spatial distribution of temperature is primarily studied in two ways. First is the vertical distribution of temperature and the horizontal distribution of temperature. We have covered the vertical distribution of temperature briefly when we were discussing the layers of the atmosphere also. So, the vertical distribution of temperature is associated with the distribution of heat and temperature vertically over the surface of the Earth, typically associated with the lower layers of the atmosphere, primarily in the troposphere. So we've already studied that our planet is covered with the envelope of air, and this air is divided into various layers, which is troposphere, stratosphere, mesosphere, thermosphere, and together which is called as atmosphere. And so when we discuss the distribution of temperature along the layers of the atmosphere, it is called as the vertical distribution of temperature. It is mainly the outcome of the interaction between the incoming solar radiation, outgoing terrestrial radiation, and atmosphere together. And in the process, the heat is distributed vertically as well as horizontally. So when there is a continuous interaction between the incoming solar radiation, certain sections of our atmosphere absorb them, reflect them, diffract them, and the Earth's surface after receiving the incoming solar radiation also reflects them back as outgoing terrestrial radiation. So the interaction of all these types of radiations along with the atmosphere helps in the redistribution of heat. And the Earth's lower layers of atmosphere in this process are heated specifically through the outgoing terrestrial radiation, which is also called as effective radiation. Therefore, the lower layers of our atmosphere are heated first, and therefore the temperature of the lower layers of the atmosphere is much more as compared to the upper parts of the atmosphere. As we move up in the atmosphere, the effectiveness of terrestrial radiation to define temperature is reduced. So other factors come into play at that point of time, not just the terrestrial radiation. So the effectiveness of terrestrial radiation remains to certain kilometers in the atmosphere only, which are closer to the surface of Earth. The decrease or increase of temperature beyond troposphere is affected by several other factors like the distance of layer away from the Earth's surface and other specific factors like its ability to absorb and trap the sun's rays, and several other factors are also responsible for it. The distribution of temperature with elevation, that is, while moving vertically up in different layers of the atmosphere, is different. The atmosphere gets heated from below through the process of conduction, radiation, and convection. And in all these processes, the heat is released, which affect the temperature of atmosphere. The lower layers near the surface of Earth are warmer. As we move up, the temperature decreases with increasing height. It is called as normal lap state where the temperature decreases at 6.5 degrees Celsius per 1,000 meter upward, and decrease of temperature with increasing height is only existing in the troposphere, that is the lowermost layer of the atmosphere. This is also termed as vertical temperature gradient because the temperature decreases with increasing height. And this decrease of temperature according to normal lab state only occurs in the lowermost layer, which is the troposphere.
In order to understand the vertical distribution of temperature, this chart and this particular diagram will be helpful, wherein as you can see that the troposphere, being the lowermost layer of the atmosphere, takes on the properties of the ground and is heated from below as part of outgoing terrestrial radiation. So during this process, the lowermost layer of the atmosphere are heated from below first, and then the heat is gradually dissipated to the upper layers of the troposphere. So in this process, definitely the lower layers of the troposphere are warmer as compared to the upper layers of the troposphere. Therefore, the temperature in the troposphere decreases with increasing height at a rate of 6.5 degree per 1,000 meter. But this rate of decrease of temperature is only evident till tropopause, which is the demarcating boundary between the troposphere and stratosphere, a layer above the tropopause.
So stratosphere is the second layer of the atmosphere wherein the temperature increases with increasing height, primarily because of the presence of ozone layer which traps the incoming UV radiation, and thus there is increase in temperature in this particular layer. So the temperature in this particular layer increases till stratopause. Again, stratopause is the demarcating boundary between the stratosphere and mesosphere, a layer above the stratosphere in the atmosphere. Mesosphere, in the mesosphere, the temperature again decreases with increasing height, and some of the coldest temperature of our Earth's atmosphere till about minus 90 degrees Celsius are found near the top of this layer, mesosphere. And in the fourth layer, the thermosphere, because it is very away from our planet's surface and it is closer to the outer atmosphere, there is again increase in temperature with height. So the temperature increases with increasing height. Temperature in the upper thermosphere can range from 500 to 2000 degrees Celsius. And why? Because it mainly absorbs the high energy incoming radiations, UV radiation, X-rays from the sun, leading to high temperature. So this particular layer, the temperature again increases with increasing height. So in troposphere, the temperature decreases with increasing height. In stratosphere, the temperature increases with increasing height. In mesosphere, again, the temperature decreases with increasing height. And in thermosphere, the temperature increases tremendously with increasing height. So this is the vertical distribution of temperature which is found on our planet across the atmosphere, across the different layers of our atmosphere. Coming to the horizontal distribution of temperature on Earth, the distribution of temperature across latitudes over the surface of Earth is called as horizontal distribution of temperature. On map, the horizontal distribution of temperature is commonly depicted through isotherms, which are imaginary lines connecting points that have equal temperatures. And you can see in this world annual isotherm maps, these are the lines which are depicting the areas of equal temperature. And in general, the equatorial areas are hot and its temperature is higher throughout the year. Generally, from equator towards the poles, the temperature decreases, and the equatorial areas, the areas which are near to the equator, generally are hot. So the temperature is high in equatorial areas, and as we move up latitudinally, as the latitude increases, the temperature decreases. The lowest temperature is at and near the poles. Definitely. Why? Because the polar region receives the indirect radiation, indirect insolation, and there are several factors which we've already discussed which lead to the low temperatures near the poles. The horizontal distribution of temperature over the globe can be studied easily by studying the January and July month isotherms. And because both these isotherm maps have extreme highs and lows are depicted in both northern and southern hemispheres, so it makes easy to understand the horizontal distribution of temperature on Earth.
In order to understand the temperature conditions existing on a planet, it is imperative to understand the pattern and movement of isotherms. Therefore, contrasting conditions are taken from two time periods in an year, that is July and January. So, the patterns and movement of isotherm is studied in July and January in order to understand the global temperature conditions existing on a planet. Normally, the isotherm runs east-west and are generally parallel to the latitudes. This trend shows the strong control of latitudes on the horizontal distribution of temperature, and generally the isotherms are straight, but they bend at junctions of continents and ocean due to the differential heating and cooling of land and water. Therefore, the isothermal lines are more irregular in the northern hemisphere because of the presence of more land in the northern hemisphere, and they are more or less regular in the southern hemisphere due to over dominance of the water in the southern hemisphere. Isotherms are generally closely spaced in the northern hemisphere, as you can see in both these images. Also, the closely spaced isotherms denote a rapid rate of change of temperature and steep temperature gradient because of differential nature of land and water to get heated and to lose heat also. So the land area quickly gets heated and also lose the heat quickly. Therefore, the temperature gradient over the land is very steep, leading to closely spaced isotherms over the land area. On the other hand, widely spaced isotherms can be seen over the ocean surfaces, indicating slow rate of temperature change and low temperature gradient, primarily because of more mixing in the ocean waters and normalizing or moderating the temperature conditions. So in July, you can see that the sun shines vertically over the Tropic of Cancer with the apparent movement of sun. It is overhead the Tropic of Cancer in July, and we have summers in the northern hemisphere. So during this time period, the regions have high temperature, including especially in the USA, Sahara, Arabia, Iraq, Iran, Afghanistan, desert regions of India and China also. So you can see in this diagram that the land areas in the northern hemisphere are heated dramatically, leading to sharp increase in temperature conditions. Hence, you have very high temperature in these areas. During summer in the northern hemisphere, isotherm bends towards the equator while crossing oceans and towards the pole while crossing the land masses. This is primarily because of the differences in the nature of land and water, the differential ability to get heated and to cool down. So land quickly gets heated as well as it cools down also faster as compared to water. So in July, the pattern of isotherms is such. You can also see that when we have summers in the northern hemisphere, we have winters in the southern hemisphere, and how uniformly the isobars are spaced because of the dominance of water in the southern hemisphere. Now coming to the January, the isotherms look somewhat like this. You have closely spaced isotherms, as you can see in this particular area. Why? Because of the sharp decrease in temperature over the land surface as compared to the gentle decrease of temperature over the water surface. So in January, as we know that the sun shines vertically overhead near the Tropic of Capricorn. Hence, it is summers in the southern hemisphere and winters in the northern hemisphere. We've already discussed this, and you can see sharp temperature gradient over the land area in the northern hemisphere, whereas in the southern hemisphere you can see, although there are is summer, still the isobars are widely spaced as compared to the northern hemisphere. A high temperature is found over the landmass mainly in three regions of the southern hemisphere, and these three regions are primarily the Australia, as you can see in this diagram, South America, and the Africa, and also in certain parts of northwest Argentina, also east and central Africa and central Australia, because they are land areas, they get heated very fast, and you can see that the extremely high temperatures are found in these areas. In the southern hemisphere, the effect of the ocean is well pronounced due to few land mass. So even though there are summers in the southern hemisphere, you can still see that the isotherms are widely spaced and the temperature is still moderate as compared to the summers in the northern hemisphere during the July time period. Here the isotherms are more or less parallel to the latitudes, and the variation in the temperature is more or less gradual as compared to the northern hemisphere during the northern summer seasons. So both in July and January time period, the patterns of isotherm help depicting the existing temperature conditions on our planet.
After understanding the horizontal distribution of temperature, the different regions on the globe on our planet can be divided according to the temperature which are found on those specific locations. And as we know, and we have studied in the previous videos, that different areas of globe receive different insolation. The areas which are near to the equator receive high insolation, and areas which are away from the equator or higher latitudes receive less insolation. Based on this, the regions which are near to the equator are energy surplus regions because they received high direct radiation from sun, and the areas which are away from the equator or higher latitudes have energy deficit. Because of this, there is a constant transfer of heat from the energy surplus areas to the energy deficit areas, and in return, the energy deficit areas also exchange heat with energy surplus area, trying to maintain a balance between the Earth's total net radiation. So based on the distribution of temperature or temperature which are found on different regions of our planet, the heat zones of our planet or the regional distribution of our temperature on our planet can be divided into three main zones. First is the tropical zone, which extends between the Tropic of Cancer to Tropic of Capricorn, that is between 23.5 degree north to 23.5 degrees south of the equator. The sun's rays are more or less vertical on the equator throughout the year. Therefore, the remaining areas are also characterized by vertical sun's rays at least once every year because of with the apparent movement of the sun. There is no winters around the equator because of high temperature prevailing throughout the year. But as one approaches the Tropic of Cancer and Capricorn, summer and winter seasons are clearly observed and differentiated with the apparent movement of the sun with the seasons around the year. So one is the tropical zone. Second is the temperate zone, which extends from 23.5 degree north to 66.5 degree north, and same 23.5 degrees south to 66.5 degrees south in both the hemispheres. So in this particular zone, the duration of day and night is longer in this zone, but it is never more than 24 hours. There are marked seasonal contrasts with the northward and southward migration of overhead sun, and thus the range of temperature between summers and winters become exceptionally very high. So these regions are comparatively warmer to the polar zone, but they are comparatively cooler to the tropical areas. Coming to the third zone is also called as polar zone or frigid zone, which extends from 66.5 degrees south to the 90-degree south, and similarly for the northern hemisphere also 66.5 degree north to 90-degree north. So these areas are very, very cold areas because they don't receive the direct radiation of the sun, and they receive direct diffused radiation of sun. So these areas are characterized by more oblique sun's rays throughout the year, resulting into exceptionally low temperature. Exceptionally low temperature throughout the year, and the length of day and night is more than 24 hours. So these areas experience 6 months of days and 6 months of nights. Days and nights are of 6 month duration at the poles. Sun is never vertically and the ground is covered with snow as temperature more or less remains below the freezing point. So these are the three main zones in which the earth can be divided based on the distribution, particularly horizontal distribution of temperature on earth. So summarizing the video, we have tried to cover up the distribution of temperature on earth, wherein we studied the temporal distribution of temperature, the spatial distribution of temperature. Under temporal distribution of temperature, we have tried to cover how Earth's temperature has fluctuated dramatically since its conception, and the temporal distribution of temperature is influenced by the Earth's evolutionary history itself, by the presence of greenhouse gases, formation of Earth's atmosphere, formation of its crust, and through various geophysical activities, how the temperature has fluctuated in its geological past. And it has remained more or less stable since the end of last glacial age. However, in the recent past, the temperature has increased due to human-induced activities, primarily due to the emission of greenhouse gases and gradual increase in the concentration of greenhouse gases into the atmosphere, which may drive the planet to hothouse state which was existing in our planet prior to 35 million years, primarily in the Eocene epoch. And while studying the spatial distribution of temperature, we have covered vertical distribution of temperature and horizontal distribution of temperature. While vertical distribution of temperature is primarily associated with the distribution of temperature along the different layers of the atmosphere, the horizontal distribution of temperature is mainly associated with the distribution of temperature horizontally across the latitude. So, in general, the highest temperatures are found in the lower latitudes, but they are seldom found in the equatorial areas. They are more or less found near the tropics, and the lowest temperatures are found near the polar areas. And this distribution of temperature is generally studied on the basis of isotherm. So isotherm maps are studied to get a picture of the temperature distribution on our globe. Horizontally, the heat zones of Earth are divided into tropical, temperate, and polar heat zones depending on the global net radiation balance of our planet, where the equatorial areas receive more insolation, hence have surplus energy, and the polar areas receive the less radiation, therefore they are energy deficit areas. So based on the horizontal distribution of temperature, the Earth can be divided into three main zones, that is tropical, temperate, and polar zones. So this was all about the distribution of temperature. In the last two videos, we have covered every aspect related to the distribution of temperature, factors of temperature, temperature distribution as temporal distribution, spatial distribution, horizontal and vertical distribution. And finally, what are the different heat zones which are found on our planet? So this covers mainly all the aspects of temperature which are in this particular syllabus. I hope this video was informative. Thank you.